Hi, section 3.3. Now we'll study some differentiation rules. Okay, let's begin with the derivative of a constant function. Derivative is the slope of the tangent line to the curve, so that geometrically we can easily see that here, once a function is constant c, value c, that is now y equal c, then slope is always 0, so that a derivative must be 0. Or if we are using definition, then here limit h approaches 0 f x plus h minus f of x divided by h. But that is same as limit with h approaches 0. Now here f itself is always c, so that the first term is c and second term in the numerator will be again c divided by h. Because top is 0, then must be 0. So algebraically, we can also prove that the derivative of constant function is 0. Now, for the power rule, earlier, when n equal 1 and 2 and 3, then we solve the problem, found the derivative, so that x to the n is same as, now in derivative is n times x n minus 1. But this power rule is true for n being any real number. So we can prove it, but we'll do it later on with some other knowledge. So we'll try to use it in this section. Constant multiple rule. Once a function is multiplied by a constant c, then for the derivative of the whole term, you can apply derivative to the function, and later you can multiply c. So constant multiple and derivative are commutative. Once two functions are summed or subtracted, then now the derivative of the whole function can be gotten through derivative of each term, and later on you can combine. Okay, here let's try to solve these problems. Okay, fx is given as a constant, then f prime x must be 0. Okay, for that one, g prime t is same as, now is constant multiple, and derivative of t is 1. That is t to the 1. 1 will go out. T to the 0 is 1. And plus 4 times, okay, derivative of t squared is same as 2, and t 2 minus 1 is 1. Okay, so let's try to simplify it. There's 5 and there's 8 t. Okay, so that's the final answer. Okay, now let's try to find the derivatives. Okay, here for function f prime equal, okay, 3 over 2 will go in front of that, and x to the, now 3 over 2 minus 1 will be half. Okay, here minus 3 will go in front of that, and then x to the minus 3 minus 1 is minus 4. You can simplify if you want. Now for this function, now you can rewrite this one in this way. Is 2 times, okay, 1 over t squared is same as t to the minus 2, and 8 times Okay, 1 over t to the 4 is t to the minus 4. So we can use the power rule. R prime t, same as 2 is constant, and minus 2 will come out, and t to the minus 2 minus 1 is minus 3. Okay, now that is 8 times. Here, minus 4 will come out, and t to the minus 4 minus 1 is minus 5. Okay, you can simplify here. Minus 4, t to the minus 3, minus 32, t to the minus 5. That's the answer. Okay, let's go to C. For that one, now is you cannot get directly some reciprocal, so that we have to separate it out. So it is square root of x divided by x squared and plus x over x squared. Now that is same as half power is 2, half minus 2 is the same as x to the minus 3 over 2 and plus. Now that is 1 and minus 2, so that x to the minus 1. Okay, now we can use the power rule. Y prime equal minus 3 over 2, and then 3 over 2 minus 1 is same as x to the minus and 5 over 2. Okay, plus. Now minus 1 will go out, and x to the minus 1 minus 1, which is minus 2. So that's the answer. Okay, for that one, if we want to use power rule, then we have to rewrite. That is down. Okay, 1 over square root x is x to the minus half power, and that is now x fourth root, so x to the 1/4 power. So here, by using the power rule, we can have minus 1/2 times x to the minus f minus 1 minus 3 over 2. And here 1/4 will come out, and x to the quarter minus 1 is minus 3 over 4. That's the answer. Okay. Now we'll go to derivative of exponential functions. Exponential functions are defined in this way. Fx equal a to the x. A is positive and not 1. For that function, let's first evaluate f prime 0 at this specific point 0. We'll try to get the derivative. Here, f prime at 0 is same as in definition, limit h approaches 0. That is basically f of h minus f of 0. So that a to the h minus a to the 0 over h. And it's the same as limit a to the h minus 1 over h. So here, that quantity is the same as now f prime 0. Now we'll try to get derivative of that function at general x for the point x rather than specific point 0. So here, by using definition, derivative of ax is the same as now limit h approaches 0. Okay, the top is the same as f x plus h minus f over x. So f x plus h is same as a x plus h, and now f of x is same as a to the x. It's divided by h. Okay, a to the x plus h can be written in this way: a to the x times a to the h. So a to the x are common, so we can put out And now we can apply this limit to this second term. So we change it into this way. But here, this portion is now same as this one, and which is same as f prime at 0. So we can conclude that the derivative of a to the x is same as the function itself times f prime at 0. Later on, by using some advanced technique, chain rule, in fact, and we'll prove that here f prime at 0 is same as here natural logarithm of a. We can prove that, but momentarily, right now, here we'll use that formula. The derivative of a to the x is same as the function itself times f prime at 0. Now, among all exponential functions, here we'll consider the function y equal e to the x. But e to the x, the number e is introduced such that the slope of the tangent line to the function at 0 is 1. That means that if you try to get derivative of e to the x at 0, then in definition we can write in this way, and which becomes here, that must be 1. That is, once you are considering that is now f of x, then that is exactly here f prime 0. So from this formula, once it is replaced by e to the x, then that must be 1. So here, derivative of e to the x is same as e to the x. So we have this formula. So derivative of the natural exponential function is the same as the original function, e to the x. Okay, we have that formula. Okay, with that knowledge, let's try to solve this problem. Find the derivative of the given function. Okay, now again, that is 1 over x. That 1 over x is the same as basically x to the minus 1. So we can use power rule for this term. Okay, for the function, now here f prime of x is same as 3 times the derivative of e to the x is same as e to the x. Now plus 4 times derivative of x squared is the same as 2x. And minus, and derivative of x to the minus 1 is minus 1, and x to the minus 2. Minus 1 is minus 2. And derivative of 3 is 0. Okay, let's rewrite this one. 3 e to the x plus 8x, and minus minus becomes plus, and x to the minus 2. Okay, that's the final answer. Okay, this is the end of the part 1, and we'll continue in part 2. Thank you.